Hi, everyone. My name is Vaidehi, and I'm really happy to be here with all of you today. A little bit about me. I am a lead software engineer at Forum, the open source software that powers online communities like Dev and Code Newbie. In my free time, I really love learning new things and sharing them with others. So these are a couple of the side projects I've done in my spare time. If you're interested in things like computer science or distributed systems or really weird, strange computing history facts, you should check these projects out and come nerd out with me. But more recently, I've kind of been obsessed with learning about something completely different and something really new to me. I've been really interested in learning about how and where we store our data. Now, you might be thinking, what do you mean you've been thinking about how and where we store our data? Our data lives in a database, right? On some server somewhere? What's there to think about? Well, it turns out there's more to this than meets the eye. So let's dig a little deeper. Everything we create and share on the internet is physically stored somewhere. However, most of us aren't thinking about how and where this data is stored. As developers, we might think that our data is ephemeral, but all of it lives somewhere. And when you work with code all day, it can be really easy to forget about the physical things that are powering our world. So let's try to learn more about the physical aspects of our jobs together. These days, the majority of all data in the computing world is stored in something called a data center. A data center is one or many buildings that store servers and all of the hardware associated with those servers. Now, before data centers were ubiquitous, we had to house all of our servers ourselves, sometimes in a single room. But over time, people found that renting out servers in a data center tended to be a lot easier than maintaining one's own server rooms. And that's how data centers themselves started to become so much more commonplace. Most of us probably aren't even thinking about whether our data lives in a data center or not. And that's because most of us rely on cloud providers to think of that for us. Cloud providers are companies that rent out servers within their own data centers. If you use any of these cloud providers, then you're actually just renting out the servers in the data centers that these companies own, which is basically the service that they provide. Now, I mentioned that renting out servers in a data center tends to be a lot easier than maintaining one's own server rooms. Now, why is that? Well, when you store your content in a cloud provider's data center, then you don't have to maintain your own machines or your own network. You also, conveniently, have access to better hardware and improved security infrastructure like backups and distributed databases. Overall, storing content in a cloud provider's data center is just more efficient than running a data center of your own. Plus, when you sign up for a cloud provider, they'll promise you things like little to no downtime, which is a really nice benefit. But what do these cloud providers actually do in order to keep things running and to ensure operability and deliver on that promise of no downtime? Well, in order to make sure that you can always access your data and in order to keep their systems reliable, cloud providers will often set up more than one instance of your server in various different locations. This is something known as redundancy, which is the idea of having duplicates of something in the event of a failure. But the trouble with having large numbers of servers is that the more servers you have, the more servers you need to power and maintain. And servers are demanding. Servers are powered by electrical energy. To take it a step further, not only do servers use energy, they also emit energy in the form of heat. But if a server emits too much heat, then it will actually overheat and fail. So servers also have to be cooled in order to stay running and operable. In fact, because of these hardware constraints, every data center will have some mechanism in order to remove hot air and supply cold air. So there's two things happening. Not only do we need energy to power servers, we also need energy to cool them down too. But just how much energy are we talking about? Well, to be honest, it's really hard to find exact numbers on any of this stuff. So I'll try to give you the best estimation based on my research. Looking at conservative estimates, data centers worldwide use approximately 200 terawatt hours a year. Now, by more generous estimates, some studies say that they consume up to 500 terawatt hours a year. So that's quite a range. 1 terawatt hour is equivalent to 1 trillion watts of energy consumed in a single hour. So for some context, the United Kingdom, which has a population of approximately 66 million, or at least they did in 2019, that entire country consumes only 303 terawatt hours a year. Now, if we choose the more liberal estimate of data centers globally consuming closer to 500 terawatt hours a year, well, now you can start to see that data centers collectively are consuming more electricity than many countries. Depending on which estimate we go with, we can say that overall, data centers currently demand somewhere between 1 to 3% of the world's global electricity. And this is pretty surprising when you think about the fact that data centers exist purely to store our data and to make it available to us. Now, if data centers are using so much of the global energy supply, it's worth asking, where does that energy come from? The electricity to power data centers depends entirely on its local power grid. Now, unfortunately, depending on where you're located, your local power grid might actually burn fossil fuels as its main source of electricity. And fossil fuels emit greenhouse gases into the atmosphere. The important thing to remember here is that the environmental impact of every data center completely depends on where its energy comes from. So if its energy comes from fossil fuels, then the environmental impact of that data center is going to be far more detrimental than a data center whose energy comes from a more renewable source. When we start thinking about the overall impact of all data centers in the world, and all of the tech sector for that matter, we can start to see how the energy that powers all of this infrastructure has a very real and very tangible impact on the world. Studies suggest that the IT and communication technology industry accounts for approximately 2% of all greenhouse gas emissions. Now, out of this 2% of emissions, the more conservative estimates suggest that data centers alone are responsible for at least 0.3% of that slice of the pie. Now, this might not seem like a lot in the grand scheme of things, but if we think about the IT sector in the context of other industries and the impact that they make in terms of emissions, it's actually quite a lot. Based on these numbers, It turns out that the tech sector has a carbon footprint that is equivalent to the airline industry, which is something that many of us may have never even thought about. I know that it came as a shock to me when I saw the equivalency there. So, what are we doing about this? Well, the answer to that question really depends on each individual cloud provider and their values. There's a great white paper that was published in 2018 called The State of Data Center Energy Use in 2018. It was written by two folks in the industry, Paul Johnston and Ann Curry. Now, this paper goes into a lot of detail about the environmental impacts of 6 of the biggest cloud providers. And it does something kind of cool. It gives each of these cloud providers a grade in terms of the sustainability of their servers. The original paper was written back in 2018, which is when I discovered it. But the authors of this paper actually went and updated it last year in 2020. So I'll be referencing the updated version of that white paper. And I mentioned that the white paper talks about many different cloud providers, and I'm only going to get into 2 of them in detail today. But I encourage you to check out the entire white paper because it's really well written and has some wonderful resources, and it's worth learning about. So let's start with AWS, which is the largest cloud provider. They've committed to run on 100% renewable energy by the year 2030. Now, AWS actually allows you to house your servers and your server instances in different zones across the globe. By my count, they have somewhere around 22 zones, but only 5 of those zones are actually carbon neutral. According to AWS's website, these are the 5 zones that they claim are carbon neutral. And if you store your data in one of these carbon neutral zones, if you provision a server in one of these zones, then AWS will purchase something called a carbon offset on your behalf. Now, when AWS buys a carbon offset, what they're really doing is purchasing renewable energy and then putting it back into the electrical grid. These carbon offsets are what makes these 5 zones carbon neutral. Now, it's really important to note that carbon neutral sounds really good, but there's a little more to it than meets the eye. If you store your data in one of these zones, you're actually still emitting greenhouse gases. In effect, you're merely just slowing down your emissions by buying that renewable power generation from somewhere else in the form of that carbon offset. Carbon offsets aren't a long-term sustainable solution because you're not actually removing carbon emissions from the atmosphere. You're just slowing down how many emissions are going out into the atmosphere, but they still go out. Despite the fact that AWS will buy carbon offsets for those 5 carbon neutral regions that I mentioned earlier, they still have other more problematic regions, like US East 1, which is located in Northern Virginia in the United States. Now, a lot of companies host their data and provision their servers in this region. And there's like a dirty little secret to this region that a lot of us don't even know about. Unfortunately, Dominion Energy, which is the power supplier for the state of Virginia and effectively for this region, they've actually doubled down on fossil fuels. Dominion Energy has taken steps to ensure that fossil fuels remain a part of their business model. And by some reports, they've actually tried to curb other renewable sources of energy like solar. As a result, this means that all of the data centers in this region, in that state, whether they're provisioned by Amazon or not, all of them are relying on that state's local power grid, which is powered by fossil fuels. And all of that, in turn, contributes to carbon emissions. Now, you'll remember that goal that AWS had of being 100% renewable. Well, despite this goal, and despite the fact that they have this entire region called US East 1, which is problematic, they're actually continuing to open new data centers in this region, even though they say they want to be 100% renewable. Actually, since 2017, they've increased their operations in US East 1 by 59%. And to make matters worse, AWS is the least transparent of all the major cloud providers, despite being the biggest. They do not do a good job of publicly reporting data on their current energy use or how quickly their energy use is growing. And this makes it really hard to know if the renewable energy that they say they're buying through carbon offsets is anywhere close to offsetting how much energy they actually use across all of their data centers. So it's really hard to make any solid claims about how well they're doing because they don't make this data very accessible to any of us. Now, if we look at Google Cloud, things start to be a little bit brighter. The Google Cloud Platform buys carbon offsets for all of its servers, not just a select handful in a few regions. In fact, their parent company, Alphabet, is actually the largest corporate buyer of renewable energy. Compared to AWS, Google has been pretty transparent about the fact that they know they can't power 100% of their servers through entirely renewable energy, at least not yet. So instead, they've adopted a different strategy. For each kilowatt hour of energy that Google Cloud Platform's servers consume, Google purchases a matching kilowatt hour of clean, renewable energy, and they add it back into the power grid. So that might mean that the energy that Google is buying could be produced at a different time or in a completely different place from the location of their data centers. But ultimately, they are actually adding new clean energy sources back into the electrical grid. And they're buying the same amount of renewable energy as all of the energy that their own servers consume in order to stay running. So even though hosting on Google Cloud causes new carbon emissions, 100% of those emissions are offset. And as it turns out, Google is surprisingly the leader in this entire sector, and they're doing much better than a lot of the other cloud providers. Microsoft is the only other provider that has met its 100% sustainability goal, and you can read about that in the white paper. Google has also made it pretty easy for their customers to pinpoint the exact usage and carbon emissions of every single one of their regions. They recently introduced something called the Carbon Free Energy Percentage, or CFE for short. And this is the average percentage of carbon-free energy that is consumed in one particular region on an hourly basis. And that percentage takes into account any carbon offsets and renewable energy that was purchased for that specific location. This transparency of data effectively allows Google Cloud Platform customers to narrow down on regions that will help them maximize on carbon-free energy and also help them reduce their carbon footprint, which is pretty cool. But more recently, Google has a new goal, which is to run their business on carbon-free energy 24/7 everywhere across all data centers by the year 2030. And they've termed this real-time matching. The idea here is to take into account what time of day it is and what season it is whenever you're generating some unit of renewable energy. And what they're trying to do is they're trying to figure out how to match that energy with the real-time demand of their data centers across all servers. So they're working towards this, and it's pretty exciting to see in the green energy space. And if they can pull it off, they'll effectively ensure that no data center ever needs to draw power from a power grid that might be burning fossil fuels under the hood. So now that we know the reality of two very different cloud providers and how they're powering their data centers and how those data centers house our content, let's take a step back and ask ourselves a much bigger question. How will the energy usage of data centers scale into the future? Well, multiple research papers have found that global data traffic is growing quite quickly. And this means that the usage of data centers is inevitably going to grow too. Over time, this is just going to demand more and more energy. This graph shows an expected case projection for how the IT industry could potentially grow over time. The estimate here is that our industry is going to use somewhere between 8 and 21% of the total global electricity demand by the end of this decade. Now, given that we're an industry that cares so much about efficiency and scalability, we probably need to collectively start thinking about this problem too. I have some good news though. Many of us have started solving for this inevitability. From a hardware perspective, some cloud providers are actually starting to build new data centers in colder climates where it doesn't take as much energy to cool their servers. Other cloud providers are recovering and recycling wasted heat from servers and reusing it in sustainable ways. One data center in Sweden actually recovered wasted heat from their servers and used it to heat 10,000 apartments in the city of Stockholm. And of course, there are companies like Stripe and Basecamp, which, as far as I know, don't even have data centers of their own, but they have dedicated themselves to becoming fully carbon neutral or carbon negative, which is really exciting to see. And each of us has agency in solving this problem too. So, what can each of us do to help mitigate the environmental impact of all the data that we create and store? Well, first and foremost, we can each find out where our data lives and whether it is stored in a region that is green and carbon neutral and powered by renewable energy, or whether it's actually contributing to the planet's greenhouse gas emissions. There's a great website that I discovered recently called the Green Web Foundation that can help you answer this question when it comes to your own apps and projects, as well as maybe some of the services that you use every single day. Now, if your data doesn't live in a green region, then it's worth our time to figure out what it might take to migrate our data into a different location or to a different provider that is carbon neutral. And if you're in the lucky position where you're starting something fresh and get to provision new servers or databases, you now have the knowledge to choose a clean cloud provider from the get-go. Another step you can take is to just simply draw attention to this issue and talk about it with your team. If you're at a small company, this might just mean talking about your cloud provider choices internally. But if you work at a larger company, especially one that might have a large enterprise account, you can pressure your cloud provider to release data and be more transparent about where their energy comes from when it comes to powering their data centers. And if they're not transparent, you can push them to be more clear with their data and try to make it easier for you as a customer to make the green and sustainable choice. All of us collectively can hold these companies responsible. It's estimated that 53% of all servers will be located at hyperscale cloud data centers by the end of this year, 2021. In other words, more than half of all functioning servers that are owned and operated are likely to be provisioned by AWS, Google, or Microsoft. So ultimately, we need to focus on getting them committed to sustainable practices and following through on those promises if we're going to try to mitigate the eventual growth that's going to happen. And thankfully, as we've seen, some of these providers are already doing just that. Now, if you work at a company that actually provides cloud services, and if you have the power and the privilege to do so, you can do even more to hold these companies accountable. There are some very active employees at Amazon that are doing exactly this, which is really great to see. To take it a step further, you can even build something to make it really easy to find information about this topic. It's really hard to find accurate statistics around energy consumption, and sometimes it's just hard to find data in general about these cloud providers. So it's really important that we make this data accessible to everyone in the industry so everyone can be a bit more thoughtful when they make these really impactful choices. A great example of a really nifty tool is something called the Cloud Sustainability Console, which is a Chrome extension. This is a great example of building something in the name of transparency. It's a really simple but useful browser extension that highlights which regions in AWS are carbon neutral. So when you log into your AWS account, you can make it really obvious to someone if they aren't running on a carbon neutral zone. Now, at the end of the day, all of us could stand to be a little bit more aware and thoughtful about the computational resources that we rely on and use in our day-to-day lives as developers. And this goes beyond data centers. This extends into the websites that we build, the data we fetch, the content we store. All of that we do as part of our jobs, but sometimes we do it without giving it a second thought. And the reality is that all of that content and data requires energy in some shape or form. And it's really important that we're mindful of that, especially as the creators of these technologies and tools. There's a really wonderful repository on GitHub that I discovered recently called the Low Impact Manifesto. It was created by a Danish company called Organic Basics, and I just love the idea behind it. They've created these 10 rules on how to make a low impact website. And they've actually open sourced these rules for all of us to use. And when I discovered this last year, I think I started reflecting back on every project and every website I'd built. And I started thinking much more deeply about all of the data and resources and fonts and images and requests I had made without ever thinking about what that actually costs and what that took in terms of computational resources. So that was a fun self-reflection exercise, and I would encourage you to do the same. The Sustainable Web Manifesto is another really great resource. It lists some really solid principles that can help us in. The Sustainable Web Manifesto is another great resource. It lists some really wonderful principles that can help us in creating a much more sustainable internet. But if you take nothing else away from this talk, I hope that the one thing that you will all do is just be aware. Be aware of the physical impacts of what we do every day, even though sometimes we can't always see them. Be aware of the impact that our industry makes on all of us and on the planet as a whole. Our industry relies upon a finite resource, even if we can't see it, and even if we don't think about it all the time. It's our responsibility to take that first step and start to learn about this stuff and educate ourselves and others. As I've learned more and more about how we store data, I've also realized that honestly, most of us don't even know what the cost of storing all this data is going to be down the road. We don't know what the repercussions are going to be. And even when you look at statistics and estimates, nobody is really sure about exactly how much of an impact this is going to make. So it's hard to make really wise decisions when you don't necessarily know the impact that it might have 5 or 10 years down the line. But despite this, I still don't feel disheartened. It might seem like all we're doing as an industry is contributing to this problem that's spiraling out of control. But there's another way to look at it too. We could also be the ones who start to change it. Historically speaking, the field of technology has often been the one to push the needle forward. And I feel like we can push the needle forward here too. I'm optimistic that we can actually set an example for other industries by making wise choices that are sustainable and keep an eye always towards the future. We're a unique group because we aren't just consumers of technology, we're creators of it. And this means we each have the power to influence and guide our industry. And I'm confident that if we all were a little bit more aware and thoughtful and collectively put our minds to the job, then we could guide it in a much more sustainable direction. If you're interested in learning more about data centers and green energy, or looking at some statistics or data or articles, please check out costofdata.dev. There's so much information out there and I couldn't squeeze it all into this talk. So I've compiled it on this little website for you to check out if you're interested. Thank you so much for taking the time to listen, and I hope you learned something.